Welcome, deep divers. So today we're jumping into physics. We've got all your notes, articles, research, and our mission is basically to pull out the biggest insights. Think of it as a journey from, well, apples to atoms. Get ready for maybe a bit of a shortcut to seeing things differently.
Yeah, it's really about getting a new lens on reality, finding those surprising facts, those aha moments
Hmm.
that might just change how you view the world, from the huge cosmic scales right down to the tiny, almost bizarre quantum level.
Okay, let's start unpacking that. We should probably begin with the basics, like motion and forces. We all kind of feel like things just naturally stop moving on their
But
own.
that's our everyday intuition.
But Newton's first law of inertia just flips that completely. It says an object just keeps doing what it's doing, whether it's sitting still or moving steadily, unless some net force pushes or pulls on it.
Exactly. And that's key because it reveals the sort of invisible players like friction or air resistance. They're usually the reason things do stop here on Earth. And this law, it's the foundation. It leads right into his second law, FMA, force equals mass times acceleration, how much oomph you need.
Okay.
And then the third law, which is fascinating, every action has an equal and opposite reaction. You push on a wall.
It pushes back on you.
Yeah.
Simple but profound.
Mm-hmm.
But things get even bigger picture, right? Like, for ages, a falling apple and the moon going around the Earth seemed totally unrelated.
Completely different phenomena seem
Until
to.
Newton connected them. He showed it's the same force gravity doing both jobs, universal gravitation.
Yeah.
Incredible. But then Einstein enters the picture.
Right, and Einstein takes it even further, almost rewriting the rules again. With general relativity, he proposed something really radical. He said gravity isn't actually a force pulling things.
Wait, not a force. Then what is it?
It's the curvature of space-time itself. Imagine like a heavy ball on a rubber sheet makes a dent.
Okay.
Mass and energy warp this four-dimensional fabric of space-time. And planets, like Earth, they're just following the straightest possible path through that curved space around the sun. We just perceive that path as an orbit.
Wow. So the Earth thinks it's going straight, but space-time is bent.
Essentially, yes. And this idea, it predicts real, measurable things like light bending around stars or time dilation. Clocks on GPS satellites actually tick slightly faster than clocks down here on Earth because of this difference in gravity's effect and the curvature.
But we have to correct for that, for GPS to even work.
Absolutely. It's a necessary correction. It's amazing, real-world proof.
Okay, mind officially bending. Let's switch gears then. From the cosmic scale down to the super small, the quantum realm. This is where things get really weird, don't they?
Oh, yeah. Everyday intuition completely breaks down here. Take light. We learn it's a wave.
Right. Spreads out, interferes.
But it also behaves like tiny packets, like particles, photons.
Yeah.
And the kicker, as you said, is that things we think of as particles, like electrons, they act like waves too.
So wait, how can something be both a particle and a wave? That doesn't seem possible.
It's one of the core mysteries, really. The double slit experiment shows it perfectly. You fire electrons one by one at two slits, and even though they go through one at a time, they create an interference pattern on the screen behind, just like a wave would, as if each electron went through both slits and interfered with itself. But here's the twist. If you try to detect which slit the electron goes through,
To observe it.
yeah, to measure it, the moment you do, poof. The interference pattern vanishes. The electron suddenly acts like a well-behaved particle going through one slit or the other. The very act of observing changes the outcome.
So looking at it changes reality. That sounds almost philosophical.
It points to something fundamental. It's tied to the Heisenberg uncertainty principle. You just can't know everything precisely about a quantum particle at the same time, like its exact position and its exact momentum. The more you know one, the less you know the other. It's inherently probabilistic, fuzzy.
Wow, okay. Deep breath. One last big question that may be the deepest. Time. Why does it only seem to go one way? Forward. Why do we see things unhappen?
Ah, the arrow of time. This brings us to thermodynamics and specifically entropy. Entropy is often described as disorder or randomness.
Okay.
And the second law of thermodynamics is pretty unbreakable. It basically states that the total entropy, the total disorder of an isolated system can only increase over time. It never decreases on its own.
So things naturally get messier.
Exactly. Think about an egg. You drop it, it breaks, lots of disorder. It doesn't spontaneously leap back into your hand perfectly whole. Or a pile of dust doesn't just assemble itself into a building. It's not strictly impossible according to basic mechanics, maybe, but it's astronomically improbable. There are just vastly, vastly more ways for things to be disordered, messy, spread out than for them to be ordered and neat.
So the universe as a whole is just getting messier, moving towards more disorder.
That seems to be the case. It started in a very ordered state, I think the Big Bang, very dense and hot, and it's been expanding and increasing in entropy ever since. That forward march towards greater disorder is what we perceive as the flow of time.
So wrapping this all up, what's the big takeaway for someone listening? What does knowing all this actually, do for you?
Well, understanding these principles, even just grasping the basics, it gives you a profoundly different way to see reality. And it's not just abstract. Your phone's processor, quantum mechanics is in there, MRI machines, nuclear physics, GPS, like we said, relativity. These aren't just theories, they're the basis for our technology.
Yeah, that's true. And maybe think about this. The world you experience, right?
Yeah.
Solid, predictable, reliable.
Mm-hmm.
It's really just what scientists call an emergent property. It arises out of this incredibly strange, uncertain, probabilistic quantum world underneath it all.
Exactly. And that feeling of time flowing moment after moment, it's tied to the universe's unstoppable journey towards, well, more disorder, more entropy. It's pretty humbling when you think about it that way. And also kind of amazing. Gives you a sense of wonder, doesn't it?